Let's explore how to implement polymorphism in Java. We will create an odd array list that will only contain odd numbers. We will want it to have all the functionality of array list. So we will extend array list. We also know it will only contains odd whole numbers. So we can have it extended with the integer data type. In order to make it so that only odd numbers can be added to the list, we will need to override some of the array list functionality. Methods like constructor, add all, set, and replace all will need to be modified so that only odd numbers are added. To override the function implementation, we will need to match the method signature from the array list exactly. We can still use the original functionality with the keyword super to access the original implementation. Let's take a look at how this works. To override the add method, we will use the override annotation. Then we will write out the method signature. This comes from the ArrayList class. From here, we can implement the modified add functionality. To start, we will check to see if the items is odd using the mod operator. If the absolute value of the element has a remainder 1 when divided by 2, then the item must be odd and can be added to our list. The actual implementation of the adding an item already lives in the ArrayList class. So we will access its implementation with the super keywords and then add the elements and then add the elements. We will continue to do this for all of the other methods. First checking if the array is odd, then leveraging the already implemented functionality from the ArrayList class. Since the odd functionality will be the same for all these methods, we can separate it out into its own public static function. Then we will use it in each function we are overriding. Next, we will override the add all methods, which lets you add collections to your array list. In the implementation, we use some of the Java streams functionality introduced in newer version of Java. Next, we will modify the set functionality so that only valid elements can be inserted. If the item is not valid, then it will return the minimum value of the integers. Now the next one is replace all method we are going to override. For replace all method, we will run the operation and then immediately remove the invalid element. The last method we need to create is the constructor. We will have it take in series of number and this will become an array for us to use in our implementation. We will use the ArrayList constructor with the keyword super, then pass in the array with the odd numbers only. Let's try this out in a separate main class. In the main class items, to do that, in the main class method, we initialize our odd array list. Let's try this out in the main class. In the main class, we have created a odd array list with number. Then we create a regular array list and add items to that. The odd list has all of the functions of the array list class, including those methods we haven't overridden. When we print out the list, the odd array list should only have odd numbers while the regular array list will have all the numbers that we have added in that. So let's try to run the program. So if you can see, 4 is excluded from this odd array list and all the numbers are added in this list. With inheritance, we were able to reuse the functionality of a given class. Then we added onto it by creating new methods in the new class. With runtime polymorphism, we not only reused the functionality of a given class, but we override it with new functionality as needed while leveraging the superclass implementation.